Today I'm going to finish up this packet of notes. So right now we're on page 9 of the chapter 9 notes up at the top. And this is just leaving off from yesterday. I just kind of ran out of time in yesterday's video because it was kind of long. So let's just finish up 3 and 4 here. And what we're doing is finding the sine, cosine, and tangent and what quadrant angle theta is in if you're given a point that is not on the unit circle. So our first step is to just draw this point over 1, down 7. So here's point P. It's not on the unit circle. What we're going to do is we're going to connect the origin to point P. We're going to drop it down to, oops, I should have put one over here. We're going to drop it down to the x-axis and create a right triangle here. Since we went down 7, the length of this side is 7. Since we went over 1, the length of this side is 1, and now we just have to find the length of this hypotenuse of this right triangle by doing a squared plus b squared equals c squared. 1 plus 49 is 50. So c is the square root of 50. 50 breaks down into 25 times 2. The square root of 25 is 5, and 2 stays underneath the radical, so 5 square root of 2 is equal to c. So there's the hypotenuse, 5 square root of 2. And again, we're going to use, because this is a right triangle, we're going to use SOHCAHTOA, S-O-H-C-A-H-T-O-A. And the angle theta, even though, yes, it is this angle, this great big angle that goes over into quadrant 4, it is also this angle here that's at the origin and goes against the x-axis. So the sine of this angle is opposite over hypotenuse, which is 7 over 5 square root of 2. But because we're in quadrant 4, quadrant 2, quadrant 3, quadrant 4, and we have to consider all students take chemistry, the only thing that's going to be positive in quadrant 4 is the cosine. So sine is going to be negative. Negative 7 over 5 square root of 2. And sometimes you're asked to rationalize the denominator, so you multiply by the square root of 2 over the square root of 2, and you get negative 7 square root of 2 over 5 times 2, which is 10, because the square root of 2 times the square root of 2 is 2. 5 times 2 is 10. So negative 7 square root of 2 over 10 with a rationalized denominator. The cosine is adjacent over hypotenuse. The adjacent side is 1. The hypotenuse is 5 square root of 2. And it's positive because in quadrant 4 the cosine is positive. So if you want to rationalize the denominator, what this becomes is 1 times the square root of 2 over 5 times 2, which is 10. So there's your rationalized denominator. And tangent is opposite over adjacent. Opposite is 7, adjacent is 1. 7 over 1 is 7, but tangent is negative in quadrant 4, so negative 7 is the tangent, and this is a quadrant 4 angle. Over here in example 4, we have a point that goes over 4. Here's a negative 4. So it goes over 4 and it goes down 2. So here's the point P. I'm going to connect it to the origin, and so after I connect it to the origin, I'm going to drop it to the x-axis. Remember, always drop it to the x-axis and create your right triangle. So I went over 4, I went down 2, and now to find out how long this hypotenuse is, we're going to do a squared plus b squared equals c squared. 16 plus 4 is 20, and the square root of 20, that's 4 times 5. So 2 square root of 5, 2 square root of 5 is equal to c. So now what we're going to do is, well, we could label this as 2 square root of 5, and we're going to use SOHCAHTOA again. Sine, oh, and here's the angle theta at the origin. Remember, theta is always at the origin, even though this great big old angle is actually theta. We can also consider this little angle inside the triangle as theta, making sure that it's the one at the origin. So 2 is the opposite side, 4 is the adjacent side. So the opposite over hypotenuse is 2 over 2 square root of 5, but it's negative because all students take chemistry says the only thing positive in quadrant 3 is the tangent. So this is a negative. The 2's cancel out, and this becomes a 1 on the top. And then if you want to rationalize the denominator, multiply by the square root of 5 or the square root of 5. So you have negative square root of 5. Square root of 5 times the square root of 5 is just 5. The cosine is adjacent over hypotenuse. Well, the adjacent side is 4. The hypotenuse is 2 square root of 5. Cosine is negative in quadrant 3 because tangent is the only thing that's positive. 4 over 2 reduces down to 2 over 1. And to rationalize the denominator, multiply by the square root of 5 over the square root of 5, and you have negative 2 times the square root of 5, all over the square root of 5 times the square root of 5, which is 5. And then the tangent is opposite over adjacent. Opposite side is 2. The adjacent side is 4. 2 over 4 is a half, and tangent is positive. So this is a positive 1/2 in quadrant 3. The next thing we're going to do is find the reciprocal of the cosine, the reciprocal of the sine, and the reciprocal of the tangent. So this section is just like the other one that we just did. The only thing we have to do is flip the sine, cosine, and tangent upside down to get the other 3 trig functions. So just like before, we have case 1, where the terminal side of ROP, well, what the heck is ROP? If you draw a unit circle, O is the origin, point R is this point right here on the x-axis. It has coordinates 1, 0, and point P is any point on that unit circle. So here is ROP, and this is the angle theta, which is at the origin. So the terminal side of ROP in standard position intersects the unit circle at P. Oh, it says P, point O is the origin. If ROP's angle is called theta, then we're going to find the sine, cosine, tangent, then we're going to flip them all upside down and get the cosecant, secant, and cotangent. So remember, when the point is on the unit circle, the x value is the cosine of theta, the y value is the sine of theta, and the y divided by the x, which is sine divided by the cosine, is equal to the tangent of theta. And then if we want to flip everything upside down, we can say 1 over x is equal to the secant of theta. 1 over y is equal to the cosecant of theta. And x over y is equal to the cotangent of theta, because they're just reciprocals of each other. You just flip them all upside down. So when you have a point on the unit circle, here's the x value, here's the y value. Remember, the sine is the y value, so it's negative 0.28. And what I'm going to do is I'm going to take that negative 0.28, and I'm going to, in my calculator, do negative 0.28. I already did it. I can negative 0.28, then press the math button, math frac. If you want to turn that into a fraction, it's negative 7/25. They're equal to each other. I like to create a fraction because when I find the cosecant, all I have to do is flip that fraction upside down. So it's negative 25 over 7. The cosine is 0.96. And if I do math frac on that, 0.96 is the same thing as 24 over 25. So the cosine is 0.96, or I'd rather write it as 24 over 25, because when I flip it, it becomes 25 over 24. And the tangent is sine over cosine, or negative 0.28 over 0.96. I wonder what that is. Negative 0.28 divided by 0.96. And math frac, negative 7/24. And then you flip that upside down, you get negative 24 over 7. So that's it, finding the 6 values on the unit circle. Example number 2, The x value is the cosine, so this cosine is negative square root of 5 over 3. The y value is the sine, which is negative 2/3. And the tangent is y over x, which is negative 2/3 divided by negative square root of 5/3. And if you wanted to, and you should, get rid of that complex fraction, multiply the top and bottom by 3. The 3's will cancel out. Negative over negative is positive, so this actually turns into a positive 2 over the square root of 5. And we'll rationalize that in just a second. Let's flip all these upside down. This becomes negative 3 over 2. This becomes negative 3 over the square root of 5. And this becomes positive square root of 5 over 2. And then the only thing we need to do is rationalize a couple denominators. Let's take the tangent, multiply by the square root of 5 over the square root of 5, and we get 2 square root of 5 over 5. And multiply this secant by the square root of 5 over the square root of 5, and we get negative 3 square root of 5 all over 5. And so that's it for points on the unit circle. And then this last page, if it's not on the unit circle, just like before, what we're going to do is plot the points, or the point. In this case, it's negative 4 and up 8. So we're going to plot that point P. We're going to connect it to the origin. And then we're going to drop the perpendiculars straight down to the x-axis, always the x-axis. Mark the right triangle. This length is 4, this length is 8. And to find this, you're going to do 4 squared plus 8 squared is equal to c squared. Let's see, this is 16 plus 64. I want to make sure you get this one right. 16 plus 64 is 80, I believe. 80 is equal to c squared. Well, 80 splits up into 16 times 5. So this is 4 square root of 5, which is the length of this hypotenuse. So now we can just do SOHCAHTOA. Oh, the r value. The r value is this value right here, and we got that as 4 square root of 5. I think actually, I'm not asking you to find the sine, cosine, and tangent. I'm just asking you to find the reciprocal. So the cosecant is the reciprocal of the sine. So this is opposite side, or I'm sorry, sine is opposite over hypotenuse. So cosecant is the hypotenuse divided by the opposite. The secant is the flipped upside down cosine, so it's the hypotenuse divided by the adjacent. And the cotangent is the flipped upside down tangent, so that becomes the adjacent over the opposite. So I've just taken SOHCAHTOA and flipped them upside down. All right, here's our theta at the origin. So the hypotenuse is 4 square root of 5. The opposite side is 8. 4 over 8 is 1 over 2. So this becomes the square root of 5 over 2. And because we're in quadrant 2, we have all students take chemistry. The only thing that's going to be positive is the sine and the cosecant, because if the sine is positive, so is the cosecant. So this is a positive square root of 5 over 2. Positive. The secant is the hypotenuse over the adjacent. The hypotenuse is 4 square root of 5. The adjacent is 4. So if you cancel those out, you just get the square root of 5. But because this is the reciprocal of the cosine, and cosine goes negative, this whole thing is negative. So negative square root of 5 would be that answer. And the cotangent is the adjacent over the opposite. 4 over 8 is a half. And because tangent is negative in quadrant 2, so is cotangent. So that becomes a negative answer. So there are your 3 reciprocals for a point that is not on the unit circle. Remember, you have to draw that triangle. If it is on the unit circle, you just use the x and y values that were given to you. But this involves just a little bit more work. And that's the end.